everyone, Mrs. Burry here. So this is your day 3 video, and we're going to talk about frequency and period in the trig graphs. So we're going to continue talking about properties of trig graphs and this week, and we're going to pull it all together in the next couple of lessons. So let's get right into it. So we're going to talk about two vocabulary words, the frequency and the period. So we've been talking about these wavy graphs. So this makes a wave, up and down and up and down, okay? And when we have a graph that's a wave in the trig functions, these waves continue on and on and on in the same pattern. They don't get any taller or shorter. They just keep going, following the same pattern forever in both directions. Okay, so when we talk about frequency and period, it's a little different than what we have been talking about. We've been talking about things that affect going up to the high point and down to the low point and the midline of our graph. Now we're going to talk about going left to right on our graph, like the distance that it takes to complete one complete wave. Okay, so talking about the waves. One complete wave, looking at this graph I have here, you can see that it's this cup shape, right? And then the cup shape repeats itself again here. Well, when we want to talk about the period of the graph, the period is defined as how long in the x-axis it takes to complete one full cycle of the graph, and that's before it repeats itself. Okay, so for in this first example, like I just said, starting here to here, that's one complete cycle of the graph, right? And then going from here to here is another complete cycle of the graph. So it just repeats itself. And you can see like, bloop, that's one, and bloop, that's another, okay? So the period of a trig graph is the length of the smallest interval that contains exactly one copy of the repeating pattern of that trig graph or function. And it's the length in the x-axis, okay? So how long in the x-axis does it take to complete one of these complete cycles? Well, I always like to start at 0, right? So starting at this boundary here, how long does it take going out the x-axis to finish the whole cycle? Well, the cycle starts here, so if you were ending the cycle, you would end where you started, so it ends there. So this chunk of space here completes that one complete cycle. And if I look at my x-axis labels, this says 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that might be hard to read, right? Remember, those are just radian measures. Normally we do degrees, but this is in radians, okay? It's just a distance, okay? So this one complete cycle occurs from 0 to 2 pi. So from 0 to 2 pi is one cycle of the graph without any repeats. So therefore, the period of this graph equals 2 pi, because that is the distance it takes to complete one cycle. Okay, let's look at this next example here. So again, we have this repeating pattern. So I always start where x equals 0. So this would be my starting point on the graph, and I need to look at the wave and figure out where the wave is completed, one full cycle. So if I start here, I go down and back up, that completes one full cup shape, right? And if I look over here, there's not much information over here to work with. But if I look over here, that cup shape is repeated again over here. So one full cycle happens between 0, and this is the ending, and the x-axis label here is pi. Okay, so this is one cycle, one complete cycle. And it happens from 0 to pi. Okay, reading the x-axis label. So my period is pi for this one. It takes pi distance on the x-axis to complete one cycle. So that's what the period is there. Let's try another one. Oh, sorry about that. I have my phone hanging precariously up here. All right, so the next one. This one right here on the next page. And so I'm going to start at 0. This is where the beginning of the wave is. And you can see this just repeats. Well, where is the ending of the wave? Well, the wave goes up, back to the x-axis, down, and back up to the x-axis. So this looks like that kind of flattened S shape, okay? It's a sine curve, and we're going to have that in the next lesson. So this shape occurs here, and you can see it repeats here. So the end of one complete cycle happens here, okay? That's the end of the one cycle, okay? This repeats it, and over here it's the start of repeating in that direction. How long does it take in the x-axis to complete one cycle? Well, it starts at 0 and it ends at 3 pi. It goes from 0 to 3 pi. That's one complete cycle. So the period equals 3 pi. That's all there is to it, guys. And this next one down here, it's a little bit below the x-axis. But let's find out. So we're going to find on the y-axis here. Here's my starting point. All right. And this one seems to go down and back up to the x-axis. That created a cup shape. Okay. And the cup shape would be repeated over here. And it's repeated over here. So I can see the pattern of the graph. The cup shape ends right here. This goes from 0 to 10 pi over 3. Remember, that's just a number. So the period for this one, the distance to complete one complete cycle, is 10 pi over 3. That's it. All right, heading on to the next one. Here's one for you to try. I'd like to see you try this on your own, so pause the video and try this, and then restart the video, and I will complete the example and you see how you did. All right, you should have been able to pause the video. Here's what I would do to complete this one. I'm going to start here. And this looks like a cup shape, not the S shape. And it looks like the cup ends here, and here's another cup, and here is part of another one, and here's another one. So that's the repeating pattern here. So it ends there. It goes from 0 to 6 pi. So my period is 6 pi. Okay? So that's all you need to know about the period. How long in the x-axis does it take to complete one full cycle of the graph? Okay? On to the next part here. The period of the trig function depends on the coefficient b in the equations. Okay? So looking at these equations, in our last lesson we learned about a. That's the amplitude. That affects how far the graph goes up from the midline and down from the midline. And now, for our period, we're going to focus on this b value. And this b value is inside the parentheses with the x, okay? And it would say like a number times sine of a number times x inside the parentheses. This coefficient b that happens in here is also known as the frequency, okay? So right under here, this is b, and they used capital B above, so I'm going to use capital B down here. The frequency is 2 pi divided by the period. But what we really want to know is, what does frequency mean? The frequency means the number of complete cycles from 0 to 2 pi distance on the x-axis. So from 0 to 2 pi distance in the x-axis. Okay? So that's what the frequency means. So if this number is 3 here, we'll have 3 cycles, 1, 2, 3, in the x-axis between 0 and 2 pi. And remember, this is our period on this side, and a period is how the distance, or how long, the distance in x for one complete cycle. Okay, so how long is it? In x does it take to complete one full cycle? So we can get this information using the graph like we did up here, or we can get it right directly from the equations. Okay, so looking at the first equation here, y equals 3 cosine x. So when we talk about frequency and period, we're going to look inside the parentheses. Okay, so if there's no number in front of the x, we call it a 1. So the b value is 1, or the frequency is 1. The graph will complete one complete cycle between 0 and 2 pi. The period, however, we're going to use this formula. The period is 2 pi over that b value that we just got over here, 2 pi over 1. So simplified, the period is 2 pi. So the period tells me in the distance of 2 pi, one cycle will be completed, okay? And that makes sense. Our frequency is 1 because the frequency is defined as how many complete cycles happen between 0 and 2 pi. And just to add a little something to connect what you had in the past, this 3 number here, your A value is your amplitude, okay? Your amplitude is A3, which means it's going to go up 3 from the midline and down 3 from the midline. All right, let's look at this next example. Y equals 3 cosine 2 times x. Now we have a number in here. All right, so, sorry about my arm. All right, so the amplitude is 1, or excuse me, the amplitude is 3 in this one, which means the graph is going to go up from the midline 3 and down from the midline 3. But what we're really focusing on now is the 2. So the frequency is just that number 2. This means that there are 2 complete cycles in the graph from 0 to 2 pi, so it's going to get a little squishier, okay? The period is calculated by taking 2 pi and dividing that frequency value you just got, 2 pi divided by 2. To finish that up, I just need to cancel off 2 divided by 2 is 1, so they're both going to become 1. So the period is pi. So if I complete 2 complete cycles between 0 and 2 pi, 1 complete cycle would happen from 0 to 1 pi, okay? Because then I have another one to happen. All right, and this last one, there's a U try here. This has a fraction in it. You can go ahead and do it with me if you want to. Remember, the amplitude is 3, which means it's going to go up 3 from the midline and down 3 from the midline in the graph. And we have a fraction now for our frequency. So let's look at how that gets done. So the frequency, or B value, is 1/2, okay? Now, our procedure to find the period is up here, 2 pi divided by whatever our B value was. So this would be 2 pi divided by 1/2, okay? Well, here's how I want you to look at this. I like to put the numerator over 1, and now I have a fraction divided by a fraction. And the calculator isn't going to be helpful with these. The numbers stay pretty simple, so let's just go ahead and do it. So the top is 2 pi over 1. You keep that. 2 pi over 1. This is division, and I'm going to change to multiply. And then I take the bottom, the denominator fraction, and I flip it. So it's keep, change, flip. Okay? So now I'm multiplying 2 pi over 1 times 2 over 1. Now, 2 pi times 2 in the numerator would give me 4 pi. 1 times 1 in the denominator is 1. So my period is 4 pi over 1, or just 4 pi simplified. So what does that mean? It takes a long distance. It takes from 0 to 4 pi in the x-axis to complete one cycle of this graph, okay? All right, next, let's do a couple more of these. In this exercise 3, we're going to be determining the period of each of the following trig functions, and again, we're only given the equation, okay? So the first thing you want to do, and they said to express your answer in exact form. This is where the calculator isn't going to help you. They don't want a decimal. So the period, the B value is 4. That's the frequency. And to get the period, you take 2 pi and you divide it by the B, 2 pi over 4. All right, then simplify that. 2 goes into both of those numbers. 2 divided by 2 is 1. 4 divided by 2 is 2. So you're left with the period is pi over 2. So it takes pi over 2 distance in x to complete one cycle. In this one, our B value is pi over 3, so we're going to have a fraction here. So to get my period, I take 2 pi and I divide by pi over 3. Okay, this is another fraction situation. So I take the numerator, 2 pi, and I put it over 1. So keep the numerator, 2 pi over 1, change from division to multiplication and flip the denominator. So that's going to be 3 over pi. Now, canceling out, the pi and the pi cancel here. And then you would do 2 times 3 is 6. So my period is 6, and see how the pi went away? It just means in an even 6 units of distance on the x-axis, this function completes one complete cycle. Here's another one. It says you try, so pause the video, give this a try, and then start it up, and I'll go over the answer. All right, so for this one, my b value is 2/3. So my period would be 2 pi divided by 2/3. Keep the numerator and put it over 1. That'd be 2 pi over 1 times, flip the denominator, 3 over 2. And in this example, this 2 here can cancel with this 2 here, and I'm left with pi times 3 in the numerator, so that's going to be 3 pi over 1, or just 3 pi. So in this particular equation, it's going to take, in the x-axis, a distance of 3 pi to complete one full cycle of the graph. All right, now we're going to put a bunch of stuff together. You had your amplitude, your midline in the last lessons, and the frequency, okay? So the amplitude is your A value, your midline is the D value, and your frequency is based on this B value, okay? So the A value is located here, the B value is located here, and the D value is located there. All right, so my amplitude, looking at this equation, what's in this spot here? 5. The amplitude is 5. So from the midline, that graph's going to go up 5 to the maximum and down 5 to the minimum. What is the equation of the midline? Remember, a midline is always an equation. We just take the D value right here and we leave the sign with it. So the midline for this graph happens at a positive 12. The line y equals 12. So that's the middle of the graph from top to bottom. The frequency definition is how many complete cycles happen from 0 to 2 pi. Now, all I have to do for the frequency is take this number right here. So the frequency is 2 pi over 365. Whatever the coefficient of the variable is here is your frequency or B value, okay? So amplitude comes from the A, the midline comes from what's in the D spot, and the frequency comes from what's in the B spot. There's a you try here. If you want to pause the video and give it a try and then come back to it, that'll be fine. This one does have a negative number on it, and remember amplitude's always positive, so we're going to ignore that negative right now. So go ahead and pause the video and try this one. All right, I'm going to go over this example. The amplitude is what's in this first spot here. That's an 8. That means this graph goes up 8 from the midline and down 8 from the midline. The midline is this D value here. So midline is always an equation, y equals -1, because remember, it's a line all the way through your graph. And the frequency is just whatever the coefficient of this variable is. The frequency is pi over 9. It means in the x-axis, you have to travel pi over 9 distance to complete one full cycle of this graph. And in our last example here, we have a graph. They want us to find the frequency given this graph. The definition of frequency was how many cycles from distance 0 to 2 pi in the x-axis. So let's locate where 0 to 2 pi happens in the x-axis, okay? So I'm looking at the labels here, pi over 8, pi over 4, 3 pi over 8, pi over 2, and this one's pi here. So I don't see enough of the graph, but a property of these wave graphs is they keep repeating themselves. So I'm going to go ahead and use this pi. This is labeled pi here. Pi distance for this many cycles. So from 0 to pi in the x-axis, you have how many complete cycles? Well, it starts here, and then it goes up, hits the x-axis, and then it goes below and comes back to the starting point. That's one complete cycle. Then it starts here, goes up, back to the x-axis, below, and back. So that's 2 complete cycles, okay? So from 0 to 1 pi distance, you have 2 cycles. The definition of frequency is how many cycles are you going to have from 0 to 2 pi? So we're just going to double it because we're doubling the distance, okay? So that would mean from 0 to 2 pi distance, instead of 2 cycles, we're going to double 2 cycles, and it would be 4. Okay? So my period is 4. If I had a longer graph, this would just continue to go like this and continue to go like that. Okay? 1, 2, 3, 4, and it would end here at 2 pi. Okay? So you would have 4 of the waves all happening. So the period would be, or excuse me, I miswrote that. The period is not 4. The frequency is 4. The frequency equals 4. The period, just to get that fixed, the period is how the distance is for one cycle. So from here to the end of the first cycle would be pi over 2. So it would be pi over 2 distance for one complete cycle. And the frequency is how many of those happen between 0 and 2 pi, and we counted off to 4. So the frequency is 4. All right, your homework for this is on Delta Math. There'll be 10 of them, and you should be able to look at your screen to answer those. I don't think there's anything to write down. And we'll have another lesson this week, and it's going to be on determining if a graph is sine or cosine and possibly tangent. So that'll be what we do on the next lesson. Good luck to you.